Good morning, Arbat. Is this audible? Good morning, Arbat. Is this audible? Reply in chat. Okay, so we are just waiting for 2 more minutes, then we will start the today's section. We are just waiting for 2 more minutes so that some more students will join the today's section. After 2-3 minutes, I will start the section. We are just waiting for 2 more minutes, then I will start the today's section. Today we are going to see the intensifier and heat exchanger. Intensifier, it is an important concept and which we are going to use in day-to-day life. And heat exchanger, you all are familiar with this heat exchanger in subject heat transfer. We already studied about the heat exchanger. So we are just going to revise the concept of heat exchanger, and we will going to see today intensifier. Intensifier, it is also called as a booster. If you are not getting any concept, then directly go to the YouTube and watch the videos related to this, then your concept will get clear. And still it is not clear, then you can call me or message me on my regular WhatsApp number. We are just waiting for 2 more minutes, then we will start the section. So here we are. Now I'm going to share my screen. Then we are starting our today's section, which is intensifier or pressure booster. So here I am sharing screen. So here we go. What is intensifier or pressure booster? We get pressurized oil through pump. Pump pumps the oil and we get the pressurized oil. But if we required more pressure than the pressure of pump, or we require very intensify or more pressure, at that time we are using the equipment called as intensifier or pressure booster. It is connected just after the pump so that the pressure produced by the pump can again enhance or intensify by using this device, which is known as intensifier or pressure booster. You can see on your screen that it is used to increase the pressure. Then we are going to see the construction of intensifier. Intensifier has two cylinders. First one is the input cylinder and another one it is the output cylinder. The structure of intensifier. The structure of intensifier is like this on your, you can see on your screen. Just focus on my cursor. It is input cylinder and it is output cylinder. And we are getting this formula P2. P2 is equals to P1 into A1 upon A2 is obtained by this relation between the pressure of these two formulas. So here A1 and A2, A1 is the area of input cylinder and A2 it is area of output cylinder. What is input cylinder and output cylinder? I already show you in the diagram. We are again going to see this. Then P1 it is the pressure of oil supplied at intensifier. So what is P1? P1 it is the pressure of oil which is produced by the pump and supplied to the intensifier. And P2 it is the pressure of oil delivered by intensifier. So the normal formula becomes P2 is equals to P1 into A1 upon A2, where P1, P2 are the pressure, input and output pressure of intensifier, where A1 and A2 are the areas of input and output cylinder. If we consider F1 and F2 as a packing friction, then this formula for pressure P2 becomes P2 is equals to P1 into A1 minus F1 minus F2 upon A2. Here we are going to see this video here, just focus on it.
Good morning friends. Today we shall study about pressure intensifiers or pressure boosters.
I already explained you about this intensifier, its theory, what is A1, A2, P1, P2, but still we are going to see this again.
Good morning friends. Today we shall study about pressure intensifiers or pressure boosters. Intensifier or booster is used to increase the pressure of oil. If we need to have high pressure, then we can use intensifiers. Intensifiers consists of two cylinders. One is input cylinder and the other is output cylinder. The diameter of input cylinder is more than the diameter of output cylinder. That A1 is the area of input cylinder, A2 is the area of output cylinder, and P1 is the pressure supplied to the intensifier to the input cylinder, and P2 is the pressure of oil which is delivered by the intensifier or which is delivered by the output cylinder. Then the pressure of oil delivered, that is P2, will be A1 by A2, that is the intensification factor, into P1, that is the pressure of oil which is given, supplied to the input cylinder. A1 is more, A2 is less. Ratio A1 by A2 is called intensification factor. It is greater than 1, and hence the pressure of oil delivered will be more than the pressure of oil which is supplied to the intensifier. And if we consider the packing frictions in input cylinder and output cylinder as F1 and F2, then the pressure of oil delivered will be P2 equals P1 into A1 minus the packing frictions divided by 8. There are two types of intensifiers.
Then here is the diagram for single acting intensifier. Intensifier, again we are going to study its two types, single acting and double acting. This is quite similar with the single acting cylinder and double acting cylinder. So here is the diagram for single acting intensifier. This is input cylinder and this is output cylinder. This is reservoir of oil, and this oil is pumped to this output cylinder by using pump. These two structure, this one and this one. It is non-return valve, or sometimes it is called as check valve. Okay. This is 3 by 2 direction control valve. DCV means direction control valves. 3 by 2 means 3 position, means 3-way, and this 2 for position. This is 3-way 2 position valve. You can see this is position number 1 and this is position number 2. This is first way, this is second way, and this is third way. Similarly here, this is first way, second way, and this is the third way. So it is 3 by 2 direction control valve. Now what is happening at the first time?
Double acting intensifier. We shall see the single acting intensifier now.
Initially, just listen to this, then I will again explain the working of this single acting intensifier.
Single acting intensifier is operated with the help of 3 by 2 direction control valves, and this is input cylinder, which is bigger in size, and this is output cylinder, which is smaller in size. The lever of 3 by 2 direction control valve is kept in this position, first position. Oil flows to the input.
Here you can see this is the hand lever, and using this lever we are going to change the position of this control valve.
Cylinder, and that will exert pressure on the piston of the big cylinder, input cylinder, and the force exerted is the pressure of oil P1 multiplied by the oil. We need to have high pressure. So pressure of packing. Three types of intensifiers. One is single acting intensifier, and the single acting intensifier now. Single acting intensifier is operated with the help of 3 by 2 direction control valves, and this is input cylinder, which is bigger in size, and this is output cylinder, which is smaller in size. And the lever of 3 by 2 direction control valve is kept in this position, first position. Oil flows to the input cylinder. It is P to A connection. Oil from pump will flow to the large input cylinder, and that will exert pressure on the piston of the big cylinder, input cylinder, and the force exerted is the pressure of.
Here what is happened, at this point P, the pump is connected. This pump is pressurized this oil, and it passes through this line, and it comes here, and at that point this pressurized oil forces this piston to move down. And what will be this force applied by this oil? It is P1 into A1. P1 and A1 are pressure and area at the input cylinder. Okay. Next, what will happen? The oil, when this piston moves in downward direction, the oil present in that region PQ or output cylinder, it forced to move from point Q, and it moves toward output direction, which is high pressure oil, because we are applying force to the oil by using this piston, and this high pressure oil is get out from this output cylinder from port Q here. You can listen this again.
Oil P1 multiplied by area of the piston of the large cylinder, that is A1. So P1 A1 is the force applied here, and that force will be exerted by the small piston here on this oil. So that force will be pressure of oil in the small cylinder multiplied by area of the small cylinder. If packing frictions of the two pistons are neglected, then P1 A1 will be equal to P2 A2. So that P2 will be A1 by A2 into P1. And if we consider packing friction, then this P1 A1 minus the packing friction in the big cylinder, that is F1, minus the packing friction in the small cylinder, that is F2. So this is equal to P2 A2. So P2 will be this P1A1 minus F1 minus F2 divided by this AB. Now we shall see operation of this single acting intensifier. When we keep the lever in first position, P2A oil flows and oil will flow to this big cylinder. That's why the piston will move in downward direction and it will push the oil, the small cylinder, to come out through this check valve at high pressure. When you shift the lever to the other position, then A to T connection is made, due to which
again when we shift this position of this 3/2 direction control wall, at this time what happens, this pump is get shunt here, this high the pump flow from the pump is restricted here, and this high pressure oil through port A is get returned through this line, and this piston moves upward due to the force applied by the spring here. Because of this, what happens, this piston moves upward, creates the vacuum here, and due to this the oil from reservoir is entered through port P inside this output cylinder. Again, we switch the position of this direction control valve, and this high pressurized liquid from pump comes through port A in this input cylinder, which forces this piston downward direction, which causes to pressurize the oil contained in that area, and this high pressure oil is moves to goes out through this port Q, and this cycle continues. Here this symbol for non-return valve or check valve. They are ensuring that oil flows only in one direction. If the oil comes in return direction, then they restrict the oil. This is the only function for this non-return valve.
the piston will move in the reverse direction. Piston will move in upward direction due to spring force. As the piston is moving in upward direction, oil is sucked from the sump or from the reservoir into the small cylinder. In upward stroke, oil is sucked into the small cylinder, and in downward stroke, high pressure oil is given out from the small cylinder. This is double acting intensifier. We shall go through it. To operate this double
So this double acting intensifier, I will explain you. So here we are going to again see the single acting booster, that how you are going to write in the examination. You have to draw this diagram here. We already explained that how to draw this diagram and what is contained in this diagram. And explanation is you can see on your screen here. So what it is telling, it is single acting pressure booster is operated by 3/2 position direction control valve. In first position of 3/2 direction control valve, oil at pressure P1. You can see this is P. Oil as pressure P1 flows from port A. This is port A continuously until this port A of input cylinder comes in this input cylinder. Oil at pressure P1 comes into this input cylinder. Piston moves downward direction, and oil with intensifier at pressure P2 is delivered from port Q of the output cylinder. When this piston moves downward, then oil with pressure P2 is delivered from this port Q. Similar, and again, when the spool of 3/2, this lever, this hand lever is called as spool here. When the spool of 3/2 direction control valve is shifted to second position, piston moves upward due to the spring force. And when this, you can see in that position, this pump is shut here, and the oil which is present in that area, in that input cylinder, is returned, is taken out, returned by this line, and the piston moves upward due to the spring force, and oil flows out from port A. During this stroke, oil is sucked into the output cylinder. At this time, when this piston moves upward direction, oil is sucked through this port A, and the cycle remain again continues. Okay. So here we are going to see this is double acting booster or double acting intensifier. So double acting booster, we are it is characterized by 4/2 direction control valve. Here you can see this is the two position, and there are four ways. First, second, this is third, and this is fourth. Here 1, 2, 3 and 4. So it is 4-way 2-position direction control valve. Only difference is that we again connect this input line to this high pressure output cylinder and this 2 direction control valve. These are the only changes in that double acting cylinder, and oil is present at both the sides of this piston here in double acting cylinder. Here oil is present at both the sides of this double acting cylinder. So again we are going to read in first position of spool of 4/2 direction control valve. First position means the position which is already shown in this diagram here. Oil with pressure P1 get enters in this input cylinder from port A. You can read here also. At this time piston moves downward and high pressure oil at pressure P2 is moves out through this port Q1 here. Okay, and when this spool of 4/2 is shifted to second position, means here at this time this oil from pump is insert in this input cylinder through port B. Here we can read here that oil under pressure P1 flows through port B of the input cylinder and this piston moves upward, and at this time what happens through this at that time the oil under intensified pressure P2 is delivered from Q2. At that time the oil present in that upward region get compressed and this oil is get delivered through this port Q2 here. So what is happen when there is a compression occurs, then at this another on another end there is a suction occurs. So there is a continuous simultaneously suction and compression occurs here. So when one way is when one side is producing output, another side is taking the input or suction stroke here. We are again going to see this video.
Intensifier. We shall go through it. To operate this double acting intensifier, we use 4/2 direction control valve. When the lever is kept in first position, B to A, B to T connection is there. Oil flows to the port A end port of this input cylinder, and the piston will move in downward direction. Oil which is there in the intensifier below the piston will flow out, and oil from the reservoir will flow into the top port P1 of the small cylinder. Oil is flowing like this. Is flowing like this. During this downward stroke, on one side there is suction of oil into the small cylinder, and on the other side there is delivery of oil from the small cylinder. When we keep the lever in the other position, there will be connection from P to B and A to T, due to which oil goes to the rod end port of the big cylinder, and from here oil will come out, goes to tank. During that stroke, piston will move in upward direction and oil is sucked from the reservoir to P2, the port at bottom of this particular small cylinder. Oil is sucked into the bottom of the small cylinder, and from top, oil which is there above the piston in the small cylinder will flow out to Q2, and it is given to the system. Applications of intensifiers.
So here we completed the study of double acting booster and single acting. In single acting booster, the alternatively the suction and output strokes are performed, but here continuously output is performing here. That's why it is called as double acting booster. Now we are going to see this heat exchanger, which is also named as heating and cooling devices. If oil gets overheated, then its good properties like viscosity, lubricity, and corrosion resistance, oxidation, stability, etc., get destroyed. In turns, the oil itself become corrosive and acidic. and it start corrosing the metal components internal. To avoid this, we need to cool this oil, and for this, we are using the heat exchanger. So here are the types of heat exchanger you can see on your screen. First one is, it is based on the construction. So first type is double pipe heat exchanger, then shell and tube type heat exchanger, then spiral heat exchanger. So what is double pipe heat exchanger? In double pipe heat exchanger, there are two pipes inside one over another are present, and heating and cooling liquid is continuously flowing through these pipes. Then in shell and tube type, uh, either heating or cooling, one oil is present inside the shell and one medium is present inside the tube. And in spiral heat exchanger, there are extended surfaces which are in the form of spiral sheets are used. And in second type, this is the plate type. So this is the fins heat exchanger. First type is plate and frame heat exchanger. Here plates are used which are kept parallel to each other and separated by some space. It is called as plate and frame heat exchanger. And for spiral heat exchanger, they are using the plates which are in the form of spiral binding. You can directly see its image on Google. The third type is extended surfaces heat exchanger, which is plate fin exchanger, and second one is the tube fin exchanger. Again, it's having another type which is pin heat exchanger. When the heat exchanger it is in the form of round bars, we refer to this heat exchanger as pin heat exchanger. On the basis of the flow, we again classified his heat exchanger into three types. First one is the parallel flow. Parallel flow means both working oil and cooling medium flows parallel to each other. Then they name as parallel flow heat exchanger. Counter flow means where the working medium and cooling medium flows in in counter direction means flows in opposite direction, then they are named as counter flow heat exchanger. And cross flow means when they are having flow at right angle to each other, then it is called as cross flow heat exchanger. Here we are going to see the diagram for shell and tube heat exchanger. Okay, so here you can see this is the tube and shell type heat exchanger. Here what is happening, this hot oil which is coming from the system, we need to cool this oil. So this cool hot oil coming inside this shell here, and it is moving like this. Focus on my cursor. It is moving like this, and this hot oil becomes cool, and it is we removing this oil through this port here. And from this tube, the cold water is coming in, and water is moving through these tubes here, and this cold water becomes hot, and we are removing this hot water through the from this port here. Okay, so this is parallel flow shell and tube type heat exchanger, because flow direction of the water and oil is parallel to each other, so we can call it that parallel flow shell and tube type heat exchanger. So description is written here. The shell and tube heat exchanger consists of a bundle of tubes properly secured at either ends in tube plates. The tube plates have drilled holes into which the tubes are fixed using different techniques to have leak-proof joint. The entire tube bundle is placed inside the closed shell, which seals around the tube sheet's periphery to form the two immiscible zones for hot and cold fluid. Cold water flows inside the tube while the hot water flows outside the tubes in the shell. For proper distribution of shell size, fluid over the tube, baffle plates are normally placed to the tube bundle. This baffle creates turbulence inside the shell side and enhance the heat transfer. You know, heat transfer is maximum in turbulence flow. For this turbulence flow, we need to put some obstacles in fluid flow. So here baffle plates are working as obstacles in the flow of fluid, so that more turbulence is created, and more turbulence is created, we get more heat transfer. So here heat is transferred from hot oil to cold water, and the cold water takes away the heat of hot oil, and hence the oil get cooled here. So here our second chapter, theory of second chapter ends here. Now we are going to see the numericals. We will see numericals in next section. So today we are stopping here. So here I am ending the meeting. If anyone having some doubts, then you can contact me on my WhatsApp number. Thank you.